Okay, so the first problem is finding a percent of a whole. So we are going to find what number is 24% of 25. So we're going to use this conversion table setup that we used for conversions, but we're going to do it with percents this time. So we have in this spot part, and this is going to be whole. So if I actually were to write that out, this would be part, and this is whole. And number always is going to be in this column, and percent is always going to be in this column. And the whole percent that we can have is 100. That's the top number that we can always have for 100%, just like on a test. And then the percent in the problem is 24, and I'm just getting that from our actual question. And remember, we are finding part of a whole, so this is the whole they gave us is 25. We're trying to find what 24% is, which is the part. So when you do that, you're going to cross multiply. This is just like our proportions that we've done before. And you're going to cross multiply. So 100 times x is going to be 100x. And 24 times 25 is 600. And then to get x by itself, right now it's multiplying with 100. So we need to divide, which is the inverse operation of multiplying. And when you divide by 100, you get x equals 6. So that means that 24% of 25 is 6. So now for this one, you're going to use your conversion table again, but we're doing it for percent table. And it's going to be part whole. And this time I'm just going to write P and W for part and whole instead of actually writing the word out, because you know what it means now. So part whole number percent. And this is always going to be 100 like we said before. And it's going to say 9 is what percent of 20? So 9 is our part, 20 is our whole, and this time we're looking for the percent, so we don't know what that one is. So you're going to cross multiply like you did before. So we're going to do the 9 with the 100 and the x with the 20. And 9 times 100 is 900. And 20 times x is 20x. So then when you are trying to get x by itself this time, remember we're going to divide by whatever is next to x. So right now 20 is next to x, so we're going to divide by 20 on both sides. And you get x equals 45. So that means the percent we are looking for is 45%. So 9 is 45% of 20. And that's the answer for that one. Now this one is asking for the percent of change. So we know the formula is big number minus small number divided by the first number in the problem. Now the key to this is when you're putting it in your calculator that you don't put this all in at one time. You want to do this first top section first and then hit the equal sign and then divide it by the first number, because if you try to do it all at the one time, it's going to use PEMDAS and it's actually going to give you the wrong answer because it's going to try to divide before it subtracts at the top. So when you put this in your calculator, you're going to put your big number, which the big number out of this problem is 36. So 36 minus the small number, which is 6, that equals 30. So you're going to hit equals and get 30. And then you're going to divide that by the first number in the problem. And the first number in the problem, I'm going to circle it, is your 6. So that comes first. So your answer is actually 5. Now, it's asking for the percent of change, so now you actually have to take that decimal that's right here, right there, right now, and you're going to move it 2 to the right this time instead of the other way around. So now we're starting with a decimal, and we want to make it a percent, so we're going the opposite direction, which is 500%. So that means 6 is 500% smaller than 36, or 36 is 500% bigger than 6. So the increase was 500%. So 6 to 36 is a 500% increase. And you have to make sure you write the word increase or decrease on every problem that is like this so that I know that that you know if it's an increase or decrease. Next problem. Okay, so we're doing the percent of change again. So remember it's big number. Let's go back and I don't think I can copy that. So anyway, we're going to do the big number, which is 6. Oops, I did that again. Okay, so big number, which is 6, minus a small number, which is 3. hit the equal sign, and you get 3. And then you're going to divide it by the first number in the problem, which is your 6 right here. So you're going to divide that by 6. So you're going to get 0.5. And when you get 0.5, remember we have to move the decimal place 2 to the right. So 1, 2, that's going to be a 50%. And it's going from 6 to 3, which 6 down to 3 is a decrease. So it is a 50% decrease. And that's your answer for this one. On to the next one. Okay, so when they give you a problem like this, you can use your percent table again. So remember, it's 2 lines down, 1 line across, and you have part, whole, number, percent. This is always going to be 100. And then our percent they gave us was 15. And our original price is the whole, so that's 50. And we are looking for the part. So when you cross multiply, you get 100. X, and remember we are cross multiplying this one with this one and this one with this one. So you get 100x equals 750 when you multiply 50 times 15, and we are trying to get rid of whatever is next to x by dividing, because right now it's multiplying with 100 times x. So we're going to divide to get rid of it, and when you divide to get rid of it, you get x equals 7.5. So 7.5 is actually what they're going to take off the amount in order to give you your sale price. So then you need to take $7.50 and subtract it from the original amount of $50. And when you subtract $7.50, make sure you line up your decimals, you get $42.50. So that is the sale price. So make sure that when you get to the end and you get $7.50, you look at it and go, wait, 15% couldn't be $7.50 because that, our sale price can't be that cheap, because that would actually be 85% discount. So you then have to subtract it from the original price of $50 and you get $42.50. So they're going to take off $7.50 for a 15% discount on $50. Next one. Okay, so for this one, we're going to draw our conversion table again. Part, whole, number, percent, 100% down here. And then our original price we don't know, so that's our whole. The sale price we do know, which is $75. And our discount we know, which is 20. So when you cross multiply, you're going to multiply 75 with 100 and 20 with x, and you get 7,500 equals 20x. Now, I just started using this percent table. It was taught to me by another math teacher, because normally I do, word for word and translate it into math terms. And I just went through this whole problem, and I came out with a different answer than I like, and it says 375. So if you actually went all the way through and got 375, you were doing the table correctly. But for this problem, because it's asking you for the original price, it won't work by just using the numbers they gave you. You actually have to do one little more step. And it's not really that difficult, but let's just do it with the conversion table this way. So we have part, whole, number, percent. 100 is always going to be here. And then if you're looking over here at your discount of 20%, 20% is out of 100. So when you subtract 20% from 100, 80% is what you get for 75. So this is, 75 is actually 80% of the original amount. So when you put that in, you'll be able to get your original amount. But if you were to actually put it in the other way and put in 20%, you're trying to find the original price, and putting in 20% is actually going to give you what 20% of 75 is, which won't help you at all. So when you put in the whole, you're going to put your whole in for 75, and your part is what you're looking for. Actually, I'm sorry, the other way around. I had somebody just walk in. You can't see them, obviously. Okay, so up here, you're going to put your sale price is your part, and your original price is the whole. So then you get 80x equals 100, or 7,500. Mrs. Glenn is getting distracted. Okay, 7,500 divided by 80 on both sides. And that gives you x equals $93.75. And that is the original price that started at before you took 20% off. So for this problem, if you are looking for the original price, you need to subtract the percent that it is first and use that percent, this 80, in your percent table, not the price that was given in the problem. And replay this if you would like to do this again if it would help you. So on to the next problem. We're going to do simple interest. Okay, for this one you're going to find your simple interest, and we have the top part tells us that we have to find two parts. So an account earns simple interest. A, find the interest earned, and then B, find the balance of the account. So once you find A, B is pretty easy. So A, find the interest of the account. So we're going to use the formula I equals capital P times R times T. So I stands for interest, P stands for principal, R stands for rate, and T stands for time. Your interest is what you're looking for, so that's going to stay I. The P, principal, is the original amount, which this is the original amount that you're putting into the bank. And then R is your interest rate, so it even has the word in there. So interest rate is your percent, so that's your R. And then the time is obviously 3 years. So we're just going to multiply these three together, and it'll give us our interest. But the first thing you have to do is convert your 4% into a decimal before you can multiply. So we have 300 times, and 4% is the decimals right here. So we're actually going to go 2 to the left, and now we have 0.04. And we're going to multiply by that. And I'm going to put these in parentheses. Parentheses next to each other just mean that they're multiplying. So 300 times 0.04 times how many years? 3. And when you multiply those all through, you get 36. So you are going to earn $36 interest on your account. And now for B, you're just going to take your original principal, which is $300, and you're going to add it to your interest that you just calculated. And that's going to give you how much you're going to have in your account at the end of 3 years. So you're going to have $336 in your account at the end of 3 years, earning 4% interest rate. So just by leaving your money in your savings account for 3 years, your account's just sitting there earning money, and you're earning $36 for those 3 years. And that's all for that one. Let's go on to the next one. Okay, so what we're going to do is we're going to multiply these three again like we did before, but this one's going to be a little bit tricky because it's a decimal in the middle of a percent. So you still move it 2 places to the left, but now we have a decimal already in there. So you're going to start in the middle of the number. So we have 2,000, and we're going to put it in parentheses, times 3.5, which 3.5 in percent, we got to make it a decimal. So right now it's here. So 2 places over is 0.035, and times that by 4 years. And you can rewind back to the problem to see that this is your principal, this is your rate, and this is your time, and we're just multiplying those three together to find what I equals. And when you multiply those three together, you get $280. And that is the interest that you're going to earn. So that is A. And B, you're adding 280 to the principal, which is 2,000. And you get $2,280. And that is your balance that you have in your account at the end of 4 years. For just letting your account sit there and earn interest. You're earning $280 on $2,000 by just letting it sit there. And that is the last question for my tutorial. Thank you for watching, and make sure you rewind and play it as much as you can to help you for the test tomorrow. See you guys. Bye.